Right, well, if I move my sheet of paper, it will reveal a Midland 2001, and it's a repair from our mystery benefactor Alan, and needs a tune-up and also wants the meter replacing. Now, another viewer sent in an illegal AM Midland 3001 for spares, so there we go, there's our meter. So he's got a original mic with it. We'll do the work on the set using our standard replacement mic. So it's wired. I've got a great mic there, what's that for? So it's wired Cybernet standard, even though they are built by Maxon. So it's had a hard life, hasn't it, on the front, but nevertheless, they usually work well. It's got all but one screw. And Alan's done the power connector, and as you will be aware, we supply these. And they're not a patent part, they're the real thing. Right, he's got banana plugs on it, so that makes it easy to connect to our power supply. 13.8 volts, no point pussyfooting around. It's on 19, it's got a, what on earth's happened to that LED? Yeah, right. I'm not saying anything. They don't have. Oh, they do. I couldn't remember whether they even had a transmit light. Anyway, it's not supposed to be amber. I don't think, as long as it's not blue, I don't think we really are that bothered. Right, so let's start making some notes. Alan, make a note of that, and it is, I think it's the 14th. Double 014882, which is November 81, so it'll be in the first batch and won't have an adjustable meter. That's, I think, how it's going to play out. Good. It sounds a bit strangled. Right, we'll switch picture in picture on. So put it in the bottom right today and see how that fares. That's what we're doing. We're doing 2.35. And then 40, 2.35, and then 1, 2.4. They don't have low power, so let's hope when I do the on the air test with Mr. Chippy I don't go looking round for a low power switch. And transmit, current is 923 milliamps, which is a lot for under 2.5 watts. Deviation, if our test set's not playing up today, wallow, is 3.2. We won't be doing the VSO because it isn't playing up unless there's been shenanigans when we go inside. Frequency, we'll do the frequency, we'll look at the frequency. test set's only been on 10 minutes, but we'll have an idea. Yeah, that does need to come up. 2779057. It's not illegally off, but it's not good. So I'll tell you what, we'll open it before we go any further. Oh, and he says the meter doesn't work. He's right about that. Now, do these have a PA? They do. So we'll plug our PA speaker in. Testing 1 2, testing 1 2, 1 2 1 2. 1 2, testing 1 2 1 2. That's fine. So that proves that. Also proves that. Right, we'll open it up. So, just done my first church service today. So, I put dinner in the oven. That gives us 20 minutes to get on with this. And then we've got a church service this afternoon. So, we'll see how it pans out. What I'd like to do next, if we can manage to, you might remember we had that Donita 1240, was it? The little set which was kindly sent in by a viewer, and we only got 1.6 kilohertz deviation out of it. I want to do the other one of those which was sent in, which cosmetically isn't as good. To say that right, cosmetically isn't as good. I want to do the other one of those to see whether the deviation is just as dire, and then that will prove as to, because I've got something in the back of my mind that that's how they are. I can't see any shenanigans. So, I'd like to do the other one of those, and that way we could come up with a modification that's legal, non-adjustable. Just what I thought. It has had the PCO message, but it's not out. Right, so what we're going to do is set the frequency. I will check it later and make sure it's still right. Getting worse, it's getting better. Oh, well, we've still got enough latitude in the crystal. Don't want it that high. I'll set it there, 4/5, because as this warms up, it's going to go higher. Oh, it sounds absolutely dire. 2779125 on the signal generator. Right. Well, it's certainly receiving the signal generator at 100 microvolts. Of course, the meter's doing nothing. So So I'm going to plug in our test instruments. I've still not got rid of this attenuator. So you can probably only just hear it, if at all. So if we switch to the synod meter, I've got 12 dB on there, and it's doing a miserable 1.45 microvolts. The 10 dB, oh, that drifted. Uh, 1.4, not much difference. And if it does 20, well, it does. It's 2. So it really needs to be under 1, otherwise there's a malfunction. Squelch. Never opens. And the threshold. Let's go down to the attenuator so you can see where I am. So I've parked it at 0.3 of a microvolt. And the squelch threshold is a ridiculous 30 microvolts. I think it's going to be the detector that's out there. Right, let's get on with the transmitter. Right, here goes. Transmit. So we're on the 3 watt scale of the test set, because it's easier to tune it. That's absolutely dead center. So is that now. So we're now at 2.7 watts. .75. After balancing all these, so they're on channel 20, they're dead on in the centre performance, so that's miles out. So switching to the 30 watt scale, so now 4 watts is down here. So just over the 3 watts now. So really these sets should be able to achieve more than 3.5. The power adjustment is actually this one when you've set all the others. About 3.2 there. Now they actually want you to mess with these ones. Now we've all seen the coil stretcher, but we're not going to play coil stretch. But it is part of the tune-up when it's not achieving the required power. These have to be placed just so. go through these few again. No, it's 3.2. It's a bit like a lot of news sets, isn't it? Well, normally they'll do 3.5 plus, but not this one. But it's not low enough to be faulty. It's a bit like, you know, when we do these Fidelity thousands and they're a 3.5 watt radio, and just occasionally I've seen one that'll do 4 watts, but they are a 3.5 watt radio, and the service manual says that anything from 1.7 watts to 4 watts is acceptable. So, and the same goes with those base stations, the Fidelity 3000. So there we go. Don't think you're being shortchanged, because if we read this, we were doing the difference between hobby meters and the commercial test set meter yesterday on UHF on the 77 amateur band, and you know, if I put this on a hobby grade meter, this will be doing more than 4 watts. Right, let's see how centered that 3.2 watts is. So channel 1, channel 40, yeah, it's spot on, because it's 3.1 watt there and 3.1 watt there. So the only way you'd realistically try and get this to be 4 watts, and it may not be possible, is you'd have to change the driver transistor for one with better gain. You'd have to test the gain of what came out and test the gain of what's going in. You'd have to change the output transistor for one with better gain, and then you'd have to look at all these capacitors for percentage tolerance and all that kind of thing. So it's a lot of work to do nothing when you're already, you know, it doesn't make any difference. Right, where were we? Let's look at deviation, and then I'll go for lunch. So I'm going to plug into the Quartz Lock 282 test set, which is behind me. Just to see whether the deviation is as daft as it looked. Wow! I'm actually reading 5 on there. Right. So it's that one there. That looks to be 2.5. So I'll go for lunch, and we'll see what we can do later. Right, so we'll have a look at what the Marconi test set makes of the deviation. Wow, we're wrong one. Wow. Well, that's now agrees it's about 2.2, so that's that done. Got a walkie-talkie here, we'll just have a listen to what that sounds like. Testing 1, 2, oh yeah, lovely. Just double check it's all on frequency, because everything will be warmed up now. Now it's warmed up, it's gone higher as I thought. Leave it there. Right, received signal generator 2779. So we'll go over to the we'll do the detector, so look at the oscilloscope first. For S9, 100 microvolts, maximise. Actually, not far out. That surprises me. Oh, I'm going to do this the other way around because I wonder if the IF's out. Let's go over to the cyanide meter. Have it nearer 12 dB. Just have a look at these. Yeah, that was miles out. That one was spot on. Right, we'll go and look at the front end. So turn it down to 4 dB. I mean, that was spot on. That wasn't. Turn the signal generator down. That's broken. Absolutely miles out. But it's not broken enough to need to replace it. It's still serviceable. Now we'll double check this one. That's still spot on. And then we'll double check that one. And recheck the front end. That needed further adjustment. See what the sensitivity is now. Yeah, well, that's about what you expect. See whether the squelch now works. So squelch to full. I've got a sneaking impression that's dirty control. Right, so we'll go to the attenuator. So it still doesn't open at any point. So the squelch preset, yeah. That's a bit more than that. That's dirty too. It's probably been in a smoker's house. That's it, 100 microvolts. Let's see where it is at the sensitive end. .3 microvolts. Not the most sensitive in the world. Let's take the test equipment out and put the extension speaker in, because it sounds a bit funny on FM, to be honest. It doesn't sound normal. I'm just wondering if this IF is ridiculously, this detector stupidly out. Just go and put the connection back in for the test equipment. And he just moved it a second ago, I've already lost it. So put 100 microvolts back on the signal generator. It might be on a false lock point, so let's go back to the oscilloscope so you can see this. So we've got lock there. Then as we turn the detector down, we've got lock there as well. And I think we've got it on a false lock. See what it sounds like now. You know what, it still sounds lousy. Go back to the other lock point. It's got to be that one. Yep, it's got to be there. Go back to the other speaker. I don't know whether we've got a duff filter somewhere. Anyway, we'll come back to receive. There's maybe a component not right. What we will do is look at this meter. These have been over tightened at some time. For people who want to repaint these cases, we did a video identifying the correct RAL number for ordering the paint, so it may be a good idea to do a search for Midland RAL paint number in my back catalogue, for those of you interested in doing the correct paint. Put the power back on. Put a whacking great big signal on the radio. What on earth's happened here? Yeah, well, I can see this radio is going to have to carry on till tomorrow, so we'll call it a day for now. Okay, so back on the video. I've changed the IF filter for one which we've taken off a scrap chassis, and that's brought the FM back to sounding normal. It's also brought the receive sensitivity down to 0.85 microvolts. Now we've got a meter here which is one that Alan passed on to me, and it looks exactly the same as this, even down to the 3 holes, but it's got a different scale because it's come off whatever, and this is a Midland. So if I take this scale out of that, put it in there, and Alan can have a meter back. So these are kind of taped together. It probably came off an AM set, this. So it's a good use. There we go. So pop the scale out. Pop the scale out. That looks all right. And we'll put some tape on it. Hence Scotch tape dispenser. Clutching up the bench. we'll worry about the illumination later. Just make sure this is actually working. I'm bound to wire it back to front. Not sure I can safely unsolder that. What I don't want to do is to melt the mechanism. It's been wrapped around a bit too well, that. So that looks nice and smart. Power on. So, key it up. It's going backwards. Power off. Try again. Key up. Hey! Receive. Good. Right, I'll worry about the meter lamp. Right, so the next day we're on Monday, and I've just had the post come and some more repairs. I've not opened them, but there's some more repairs come from Mr. Benefactor Alan, so it's interesting we're doing his set today. I've also, it did strike me that there was a possibility I had a better front for this, and I've just put his knobs through my dishwasher, and I think that this is a better front. So I'll give him his other one back as well. So although that's got some wear on it, I don't think it's as bad as the one wherever I put it. This is too bright, and that's a 33 ohm resistor. Now the service manual says it's 180 ohms. That's a big difference. So I'm just going to get my kit of resistors out and just see what 180 ohms does. So I'm just going to hold that in place. Yeah, that's far too dim. So 33, let's go up to 47. Because the aftermarket bulb's going to be different current consumption, let's put 47 in, see if that makes it better. Let's see what 68 does. I'm thinking that's probably it, but we'll try 100. We'll have the 100. The dimmer you have this, of course, the longer the lamp's going to last, isn't it? Good. So we'll put our 2-watt resistor kit to one side. Probably lose that as well. Right, we'll fit this. And then it should just be a matter of putting it back together. Don't know what's happened there, but I don't like it. That gives us that brightness. Right, so let's look at these fronts. So see, all the lugs have broken on the one he sent with it. It's been painted. Anyway, I'll send him that back with it, but we'll put this one on. William McPhee. As I was saying, I'll put these knobs back on. And the channel one unusually still has all the skirt writing on it. Good. Right, well that should be it. I've just probably got to get the meter light central. Oh yes. Good. Right, final test time. Let's go back to the cyanide meter and see where our cyanide now is. Right, that's 100 microvolts. That's 1 microvolt. Get a new cyanide reading. So with the filter changed, we're now getting 0.72 of a microvolt. And deafness on receive can often be the 455 filter, but it can also be the 10.695 filter. And I've lost my pen because it's on the floor. So 0.72 for 10 dB, 0.69, and for 20, yeah, it's now 1.25, we'll call it 1.3. So the meter, which is non-adjustable on this model, let's put 100 microvolts on. There we go. So I've got full scale deflection because it's going to be a bit generous. So S9 is in fact 100 and what? So it should be there. No, it's less. It's a generous 60 microvolts. So I'm not adding presets because this is the Mark 1 and it shouldn't be adjustable. That was a later improvement. The danger here, because you've got the 3 versions, you've got the one with the preset there, which is where low power would be on anything else with this chassis. You've got the one with no preset, which is this one. You've got one with the preset on the back of the meter. The danger is if you start modifying them, then you don't have a Mark 1, Mark 2 and Mark 3, and I think the collectability has gone out of the window. So non-adjustable, and it's 70 microvolts. They're fine, they're fine. Meter replaced, 100 R2 watt. What's our transmit current now, just to fill in the 950 milliamps. And the meter on transmit bangs across to about 8, so we'll just make that a bit less generous, considering the set's doing 3.2. Again, that needs a bit of a spray. I really think this has been in a smoking environment. There we go, that's now reading 4. That's psychological. Good, so that's everything except the test on the built-in speaker. We're also going to test his mic. Go over to the... I'm happy everything's set up now. Go over to that speaker. Yeah, so that's worked out okay. But the big thing was the funny. Although it was receiving okay, it was funny. It wasn't doing the normal FM hiss, and it was the filter. So that's that. So that, at least that got recovered off another set, scrap chassis. Right, let's see what happens with his factory mic. Wallow. Wow, I can't see any audio on it. Oh dear. Testing 1 2, testing 1 2 1 2 1 2. That feels a bit like it's going to be a dirty switch. So although we don't do mic repairs, looks like once again we're doing a mic repair. So if we did want mic repairs, it would actually work out as a separate contract for repair. So we'd end up with a £16.50 bench charge. So it would make them expensive. They're very time consuming to repair. You can easily spend 40 minutes doing a microphone, and that would be how it would work. And if I'm just doing something like this, well, we can usually be stupidly generous. I think we've got a dirty switch. I don't know whether this mic came with this set. I'm just going to turn the set off because I'm going to do this, and that would not be doing the set any good. Try and clean those contacts. Right, switch back on. Transmit. Wallow. Wallow. So we used our last mic insert, didn't we, the other day? So is this mic insert duff? Back to our hand. And I think we have a duff insert. Yeah, that's open circuit. So out of stuff Alan has kindly given us in the past, we've got a Midland DM2 insert, and we've also got this what looks to be a high quality one. So let's get our meter on that and see if it's somewhere near. Right, so that one failed, so we've moved over to the Midland one. So again, it's the one he provided, and I've put some glue on that, and hopefully everything will go back together this time. I suppose I'm glad the other failed whilst it was here. Now I can feel there's a bit of pressure from the pad, so it's holding it in place as well as the glue. So let's see how many screws we can put in. Charge him a token £3, but it's a 40-minute job. Doesn't matter which way we look at it, it's a 40-minute job. Right, meter away. That's 3 of the screws. Right, but other than that, it looks immaculate. The trouble is, you're going to pick these up on eBay for a lot of money and they're still not going to work, are they? Voila, we've got the right deviation. Testing 1, 2. Testing 1, 2, 3, 4, 5, 5, 4, 3, 2, 1. 1, 2, 1, 2. 1, 2, 1, 2. 1, 2, 1, 2, 1, 2, 1, 2. And let's just compare that. I'll put that near the microphones. Testing 1, 2, testing 1, 2. Obviously we're doing on the air test, and we'll be listening in more detail on the base station. Testing 1 2, testing 1 2. I think ours is a bit crisper. But there we go, at least we've got the thing working for him. So it just remains now to put the lid back on. Forgot to switch the soldering iron on. Turn the hand portable off. So quite a lot wrong here. I'm just going to pop the power supply up to 14.4 volts to see what the transmit power is at the kind of alternator output our car is. Should put picture in picture still is on. So we'll just go into camera number 1. We'll go on, we're on the 3 watt scale. I'll just key up for a fraction at 13.8. It's beyond the 3 watts as you can see. So just pop the power supply up. So there we are at 14.4. And it's doing 3.6 watts. So that's the reality of it. Just go back to 13.8. He's doing about 3.3. I say this is on our commercial meter. Now, how did I kick the solder on the floor? So a lot of time into this again. You know, I've had to do this over 2 days. So just the tune-up turned into sorting out the filter. That meter's time consuming. So I'll look forward to opening his parcel later on today. See what else he's sent. Right, own speaker. Yep, that sounds like it works. Just put some of these screws in. Switch picture in, picture off. I'm sure Mr. Chippy and I all look forward to an on-the-air test with this tomorrow. Oh no, tonight. And here we are. See if we can find something a bit less black than what he sent. There we go. It's not exactly a chrome plated screw, but it's not black. We'll send his front back with it. There we are. Right, test equipment off, and we'll plug it into the aerial and see if there's any good buddies at 2:30 in the afternoon on a Monday. One nano, Roger. Oh, good grief, we've got some skip. "19, Roger." There we go. And it sounds normal and not strangled and funny as it did before. So there we are. So thanks for watching. Midland 2001, extensive service work to that, and at least we've been able to get something to work in his original existing mic. Thanks for watching.